Now we're going to look at intersections outside the circle. Outside the circle. So this leads us to theorem 10.13, angles outside the circle theorem. Now, they have a lot of names, but I want you to look at the pictures first, okay? I need you to notice that A in all three pictures are outside the circle. So the first one is called secant because the two lines are secants. The next one is called secant tangent. You can see this right here is the tangent. And then we have something called tangent tangent, and you can see both lines are tangent to the circle. So regardless of the name, I need you just to notice the location of A. A is on the outside. It's two lines intersecting outside the circle. So it states, if a tangent and a secant, two tangents, or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So the last, when it was inside, we added. Now this is going to be subtraction. So if you will look here at these pictures, on the first one with the secant, it's intersecting outside the circle. You can see that it is intersecting this arc here, which is DE, and this little bitty arc here that is BC. So this is how you would find the measure of angle A. You would simply take 1/2 the biggest arc, the measure of DE, and subtract the measure of BC. So instead of averaging, now you are subtracting, but you have to start with the biggest arc, subtract the small arc, subtract them, take half, that is the measure of angle A. Now, looking at the next one, you can see the big arc is DC, the small arc is BC, so with a secant tangent, it operates the same way. The measure of angle A is going to be 1/2 the measure of arc DC, subtract the measure of arc CB. So even though it has different names, it's the same formula. Now, tangent, tangent. So if you'll look here, this is the whole big major arc, and this is the small arc. Now you can see this is going to take up the entire circle, but it's okay. So you still just say the measure of angle A is equal to 1/2 the measure of the big arc. So this is BDC, subtract the measure of the small arc, CB, subtract them, and take half of them. So I don't want you to get too concerned with the name secant, tangent, tangent, tangent. I just need you to notice where A is at. It is outside of the circle. So you subtract the small arc from the big arc where the angle's intercepting them, and you just do the formula. So let's move to these problems. Now I need you to notice again what is going on with problems 6, 7, and 8. All right, G is outside, P is outside, this angle is outside. So 6, 7, and 8 will be dealing with theorem 10.13. So it says find the variable. So in number 6, X is the variable. So since G is on the outside, we are going to subtract these. 170 is the big arc, and we will subtract 72, which is the small arc. It's intercepting those arcs. So 170, subtract 72, okay, that's going to be 98. Half of 98 is going to be 49 degrees. Question 7, it says to find X. Now, this is the tangent tangent. We do have 92, but we do not have this arc going around. But what we do notice is the 92 is from here to here. Well, how can we find the rest of it? Well, it's kind of simple. There's 360 degrees in a circle. If I subtract the 92 from that, that is going to give me what's left over, which would be 268 degrees. So this arc is 268. So now P is on the outside, that's where X is located. So X is 1/2 268, subtract 92. Calculate that, 268 minus 92, take half, you should get 88 degrees for X. So that is the tangent. Now, sometimes if they do not give you enough, you would call this X, and this would be 360 minus X. So sometimes algebra pops up, and that's the way you would do that. Now, question 8, okay, this is a tangent secant, but again, don't get too concerned with the names. What I really need for you to know, this is one arc, this is the other arc. Now, 38 is given to us, so this is where we have to know what the formula is saying. It is saying the angle 38 is equal to 1/2 the big arc subtract the smaller arc. So now we have an algebraic equation. So again, I'm going to multiply this side by 2 and multiply this side by 2 to make that fraction go away so I don't have to deal with it. So this is 76 equals 180 minus X. I am going to subtract 180 from both sides, and that is going to leave me with 104 degrees equals X. Now, that is all of the theorems from this lesson. Now, these last problems, okay, I need you to pay attention to what we're talking about. So it says find the measure of the angle or the arc, okay? Now, the first thing I need you to notice, this is inside. So when you think inside, you are going to add, okay? So you're going to add. So it's 1/2 of those added. Now, this one, number 10, I need you to notice that it is on the circle. So if it's on the circle, you're just going to do 1/2 of the angle. And then question 11, okay, notice that it's outside, so I need you to think subtract. Now that's basically the 3 theorems that we've looked at, and this is dealing with arcs and angles. So let's go back to number 9 and let's solve for 1 and 2. Now, number 1, notice, look straight across. You have this arc, and it's inside. So the measure of angle 1 is going to equal 1/2 131 plus 33. So the measure of angle 1 is going to be 1/2 plus 164. So the measure of angle 1 is going to be 82 degrees. Now, if angle 1 is 82 degrees, this angle 2 is going to be a linear pair. So the measure of angle 2 is going to be 180 subtract 82, okay? So the measure of angle 2 is going to be 98 degrees, okay? Question 10, it is on the circle, so these act like inscribed angles. So if this is arc 1, so this is the measure of arc 1, you look across and you are going to double it. So double 82, that is going to be 164 degrees, okay? Now, again, if that's 164 degrees and then this makes up the rest of the circle, then the measure of arc 2 is going to be 360 minus 164. So the measure of arc 2 is going to be 196 degrees. And finally, question 11. Notice it's outside, and these are the arcs that I am dealing with. This one and this one. Now this one you have to know kind of some rules. This 64 is an inscribed angle. So if I move outside, that's going to tell me if I double 64, that arc is going to be 128. To find this piece, I need to do 360 minus 128. So that's going to give me 232 degrees. Now those are the two pieces of the puzzle that I need. So the measure of angle 1 is going to be 1/2. 232, subtract 128. So the measure of angle 1 is going to be 52 if you calculate that. So 52 degrees. Now I just want to put everything together that we've done so far with angles and circles. I made this graphic for you. If we were in school, you would have this as your graphic organizer. But this is talking only about measures, okay, measures of angles and circles. So really what I need for you to do first is to determine the location of the vertex. So if the vertex is at the center, it's simply the central angles measured. That's 50, that's 50. That's the easy one. Now the vertex is on the circle. Here, this inscribed angle, okay, it is going to be 1/2 of that arc. Now, this is the first case that we looked at today. This is on the circle. I like this one because it's color-coded. Angle 1 is going to be 1/2 of that red arc, and angle 2 is going to be 1/2 of the blue arc. So if it is on the circle, it is 1/2 of that arc it's intercepting. Now, the vertex inside the circle, again, I like how this one is color-coded, okay? I need you to look for 1. Angle 1 is going to be 1/2 of them added. So arc DC and the arc AB. Now, really, angle 1, if you find it, you don't need 2, but 2 is also behaving in the same way. It is 1/2 of AD and BC because those are the ones opposite of it. So this one, okay, when it's on the circle, you are going to take 1/2 after you add them. I like for you all to think that you would average them. Now again, the vertex on the outside of the circle, okay, this is outside, this is outside, this is outside. Yes, it's made by secants and tangents, but you don't have to worry about that. Just worry about where it's at. Again, I like these because these are color-coded. You take the big arc and subtract the smaller one. Take 1/2. This one, take the big arc, subtract the blue, take 1/2. The third situation, take this arc, subtract the small one, take 1/2. Okay? So this one here, these you add, these over here you subtract. Okay? So here you can find verbal descriptions of everything, and I'm going to put this in your module so you can see what this looks like and have one-stop shop for everything that's going on with the angles.